Hello, and welcome to Chapter 1 of your 7th grade science book. You may have noticed on the notes that they were labeled as 8th grade Chapter 1, and the reason for that is that the 7th and 8th grade book have the same materials in them, and I had the notes that I had made for 8th grade previously. So, how do scientists work? When we think about science, a lot of people have many different ideas, but basically it's learning about the natural world and describing that knowledge that we gain through exploring and through experiments. Scientists are going to have to use many different skills to explore the natural world, a few of these being observing, predicting, making models, and classifying. Observing is using one or more of your senses to gather information, and often if you take one sense away, the other senses tend to get a little bit more alert. For example, try closing your eyes. See if there are things that you notice in the room around you, either through smell or touch or sound. There are two main types of observations. The first one being quantitative, and a quantitative observation deals with numbers. A qualitative, the other type of observation, deals with qualities or descriptions. To give you an example, if you look at this image, you could say that you see 3 wolves pictured, and that would be a quantitative because it has a number. You could also say that you see a black wolf, a white wolf, and a gray wolf pictured, and that would be a qualitative because it's a quality of the animals pictured. Organizing data is another critical part of our job as a scientist because the data can be very overwhelming. You collect a lot of different data, and without organizing it, there's no real way to interpret it. So, for example, in this jar of candy, we would likely use color to classify them. That would be the most obvious, but there may be other ways that you would want to classify those M&Ms. Models are quite important because there are so many things in science that we are not able to easily observe. For example, a human heart. We can't observe that, so we use models to study that. I'm sure if you take a second and think about it, you can think of a lot of different examples of models, and they may be in science or they could be in your everyday life. An inference is based on reasoning that you have from prior knowledge and from what you've observed. Inferences are not a guess. A prediction is a little bit different. It's when you make a statement or a claim about what will happen in the future, but you base it on past experiences or evidence. So the big thing to remember is that an inference is about something that's happened already, and a prediction is about something that's going to happen in the future. So a prediction might be that every Wednesday we have cheeseburgers in the cafeteria. So this Wednesday, I think we will probably have cheeseburgers in the cafeteria. That would be a prediction. Now, obviously, you can look at the lunch menu and see, but that's an example of how you would make a prediction. An inference would be, typically, I like most of what we have for school lunch, so I'm going to try this chili dog today that I've never had before because I think I will like it because I've liked prior meals in the cafeteria. Now, guys, just to quickly say, when you see things like to practice at your lab tables, homework problems, those are things that are done in class. You do not have to do them. You are welcome to do them. They're done as extensions to help you look at the material more, the activities in the book, but you will only be graded on the materials that are actually assigned to you in your Google Classroom. So going back to the notes, empirical evidence is simply evidence that's collected using the scientific process. So you need to be using a scientific method, describing specific observations. Data is just all of the evidence you collect. So whether those are facts or figures or qualitative evidence, such as things like smell or color, those are all things you record, and the collection of all of that data together is referred to as empirical evidence. So pseudoscience is fake science. The prefix pseudo means fake or false. Typically, it's used to describe something that appears to be something it's not. Pseudoscience is a set of beliefs that often tries to use science to legitimize what they're saying, but it doesn't use the scientific processes necessary to be considered true science. Now, keep in mind, pseudoscience would be something like astrology. It's not saying that astrology is wrong or bad, it's simply saying that it is not science. Anything not based on scientific evidence and the scientific method can't be considered science. There are also two types of reasoning we need to discuss. One is going to be objective. Objective reasoning is absolutely critical in science because objective reasoning is based purely on evidence and facts. You do not allow your personal feelings, morals, personal values should not come into play if you are making an objective decision. Subjective reasoning is based on personal feelings or values and morals and things like that. Both types of reasoning are very important in our everyday life, but for science, we need to use objective reasoning and leave our emotions out of decisions we make. One thing we like to remind everybody when you're looking at science versus pseudo, science uses objective reasoning and pseudoscience tends to lean towards subjective. They tend to like to try to manipulate science to support something that they are emotionally attached to. Not always, but often. That's something you see. This is a very, very good Bill Nye video that shows us the difference between pseudoscience and science. I will be uploading the worksheet to the website so that you can watch the video and complete the worksheet while you do it. If you have any trouble getting onto that video on YouTube, please send me an email and let me know. So experiments. When you design an experiment, the first step is always going to be inquiry, which is simply asking a question. You will gather information around the natural world, and then it's going to come up with, you're going to come up with ideas of what you think explains what you saw or other questions that may have come out of it. And then you take that question, often that's related to some type of problem you may want to solve, and come up with a hypothesis. When we talk about some type of problem solving with scientific experiments, an example might be that if you drink a lot of soda, you may want to try to use a whitening toothpaste. And you might want to know, does the charcoal toothpaste that I saw at the store really whiten better than the other ones? Your problem is that you want whiter teeth. You're going to propose the question and then perform an experiment to determine which one would whiten your teeth the best. Now, in talking about that experiment, it's important to point out you would not perform the experiment on yourself. That's an example of being subjective in science, is making yourself part of the experiment because you are already emotionally invested in what you want the outcome to be. So it's always important if you are doing an experiment in science to never ever use yourself as a test subject. So once you have your science and you've done some inquiry and research into it, you're going to next follow the scientific process, which we call the scientific method. You have to identify what are your variables. Variables are the things that you are studying, manipulating, and recording in an experiment. There are two main types. The first being the independent variable. That is the one you are manipulating. In the previous mentioned experiment, the independent variable would be the type of toothpaste that the individual is using. The dependent variable is what changes in response to the independent variable. In the previous experiment, it would be how white your teeth got. Now, in the book, these are called the manipulated and the responding variable. I personally, in 20 years of science, have not used those terms used very commonly. I tend to hear independent and dependent. So make sure you're comfortable with both. Independent being the manipulated, dependent being the responding. It's also extremely important that you only look at one variable at a time. If you are trying to determine the teeth whitening experiment and you used both types of toothpaste or three types, however many types you were looking at, you wouldn't possibly be able to know which one was successful in whitening your teeth. Evidence and opinion. So evidence in science includes observations and also conclusions that have been and are able to be repeated. One of the most important things about an science experiment is that it can be replicated. If nobody else can replicate what you've done and get the same results, then it's not a valid experiment. So you would use your observations, your conclusions, they need to be able to be repeated. They have to, the thing with it is they may or may not support what you actually thought was going to happen, and that's okay. A hypothesis does not always have to be supported for an experiment to be considered successful. An opinion, on the other hand, is just an idea. You may or may not have formed it from evidence, but it's not been confirmed by evidence. So it's very critical that you take the time to look at things and figure out, is this evidence or is this an opinion? Is it fully backed by facts? Scientific claims are important to analyze because, and I'm sure you even see this in today's society, we're constantly inundated with new claims and ideas, take this to live longer or take this to lose 20 pounds. Having an idea about how science works will allow you to look at those claims that you may encounter throughout your life as you grow older, especially, and you have to make important decisions about your health and things you purchase at stores. Having a scientific background, which we're going to learn in a minute, is called scientific literacy, will help you be successful at that. So how do you research these scientific questions? In order to make decisions and or design an experiment, you need to have relevant and reliable background information. This can be especially tricky when you're researching on the internet because there are so many websites where information isn't reliable. So how do you, as a student, figure out when information is valid and reliable? Websites through universities, a museum, or the government are often sources of reliable information that you can trust. So if it was to end in .gov, that means it's a government website, and you would consider that reliable. So we're at the end of this information. One more thing that I do want to talk to you about that we didn't really talk about on here is the scientific literacy. I'm going to go back here. There we go, scientific literacy. I'm going to get on this a little bit further. This is having an understanding of scientific terms and principles well enough that you know how to ask questions, evaluate information, and make decisions. I cannot stress to you how important this is to you, especially in today's society with what we're going through with the COVID-19 crisis and things of that nature. Being able to understand and read scientific information and actually digest it can help you become an educated consumer as you grow older. So that is the end of the Chapter 1 notes. I will have all assignments posted on the Google Classroom for you. Thank you for listening and going through these with me. And if you have any questions, as always, please don't hesitate to send me an email.